Hello everyone, welcome to Explore Hop. For this example, we're told to find the global maximum and minimum values for the function below on the interval from -1 to 2, and the function we're given is the function f of x is equal to 1 over 4 times x to the 4 minus 2 over 3 times x cubed minus 1 over 2 times x squared plus 2x. Before we begin to find any values, we need to recognize that the maximum and minimum values of the function either occurs at an endpoint or at a critical point. Let's first check the two endpoints. So we will evaluate f of x at x equals -1 and x equals 2. So f of -1 is equal to 1 over 4 plus 2 over 3 minus 1 over 2 minus 2. And this is equal to 3 over 12 plus 8 over 12 minus 6 over 12 minus 24 over 12. And this is equal to -19 over 12. And f of 2 is equal to 1 over 4 times 2 to the power of 4 minus 2 over 3 times 2 to the power of 3 minus 1 over 2 times 2 squared plus 2 times 2. And this is equal to 4 minus 16 over 3 minus 2 plus 4, which gives us 6 minus 16 over 3. And this is equal to 18 over 3 minus 16 over 3, which is equal to 2 over 3. Now we want to check the critical points. Let's first find the critical points. And to do this, we want to first find the derivative of f of x, then set the derivative equal to 0. So applying the differentiation rules, we get that the derivative of f of x is equal to x cubed minus 2x squared minus x plus 2. Now we can set the derivative of f of x equal to 0. And we get that x cubed minus 2x squared minus x plus 2 equals 0. And we can factor this polynomial by grouping. So if we common factor out an x squared from the first two terms, we get x squared times x minus 2. And factoring out -1 from the last two terms gives us negative x minus 2. And this is all equal to 0. And now common factoring out x minus 2, we get x squared minus 1 times x minus 2 is equal to 0, which means that x plus 1 times x minus 1 times x minus 2 is equal to 0. So x is equal to negative 1, 1, and 2. So in the interval from negative 1 to 2, the critical points occur at x equals negative 1, 1, and 2. Now we need to check the critical points. Notice that x equals negative 1 and x equals 2 are endpoints as well. So all we need to do is evaluate f of x at x equals 1. So I'm just going to rewrite the value of the function at x equals negative 1 and x equals 2. And now let's evaluate f of x at x equals 1. So f of 1 is equal to, from our function, it's equal to 1 over 4 minus 2 over 3 minus 1 half plus 2. And this is equal to 3 over 12 minus 8 over 12 minus 6 over 12 plus 24 over 12, which gives us 13 over 12. Now, comparing all the values we've obtained, we can see that the largest of these values is 13 over 12, and the smallest of these values is negative 19 over 12. So therefore, the maximum value is 13 over 12, and it occurs at x equals 1, and the minimum value is negative 19 over 12. And it occurs at x equals negative 1. And that's it for this example. Thank you for joining us. See you in the next lesson.